Set it up. And then we have some commentary. They have to clean this stuff up. Wait, you got it to work? Yeah, that's good. Yeah. She said it's fine.
It has to go straight.
Ready.
Set. Go.
Oh, what? Yes!
Group 2, period 4, Daniel Berg, Jesus Fugon, and Woobin Kim. This is our project. Our project starts off with the car accelerating down the track. The car then hits the balloon, which falls down and hits the first domino. The domino then hits each other all the way to the last dominoes. And then the last domino hits the ball, which pushes the car down and hits the battery with its front foil. Metals conduct electricity because of their structure. If you take a block of any metal, it would be made up of lattice of atoms surrounded by a sea of electrons that should have been in the outer electron shell. There is a reason for this behavior. The metal atoms are so large that the outer electron shell is very far away from the nucleus. The positive charge on the nucleus pulls the electrons into a cloud around it. If the distance between the positive and negative particles is very high, the strength of attraction between them would also be very weak, and thus the electrons move out of the orbit and into a sea of electrons around all the atoms of a metal. That is also why metals have a large affinity to lose electrons in any chemical reaction. This sea of electrons carries a negative charge. When electric current is applied to one end of any metal body, these electrons take the electric charge up and carry it to the other end. That is how metals conduct electricity.
Batteries convert chemical energy into electricity. Batteries are made up of one or more separate sections or cells containing a chemical called an electrolyte. Each cell has two electrically conductive electrodes immersed into its electrolyte. The electrodes are made of different materials. One releases electrons into the electrolyte and the other absorbs them. When an electrical device is connected to the electrodes, an electrical current flows through and it provides electric power from its operation.
For the balloon, we used vinegar and baking soda, which produced the carbon dioxide, which blew up the balloon. We used 15.9 milliliters of vinegar and 113 grams of baking soda.
To get the carbon dioxide, we used a milliliter to gram stoichiometry problem, which we have here. To get the explanation of vinegar and baking soda is the acidic acid reacts with the sodium bicarbonate to form carbonic acid. It's really a double replacement reaction. Carbonic acid is unstable and it immediately falls apart into carbon dioxide and water. The bubbles you see from the reaction come from the carbon dioxide escaping the solution that is left. Carbon dioxide is heavier than air, so it flows almost like water when it overflows the container. It is a gas that you exhale, though in small amounts, because it is a product of the reactions that keep your body going. That is how it works.